Welcome to the course Business Analytics and Data Mining Modeling using R Part 2. So, this is the last topic of this particular module, time series forecasting, and this particular topic is on smoothing methods. So, we have talked about different types of methods which are popular for time series forecasting. So, we are now going to start the last type of method that is quite popular for time series forecasting. So, this is smoothing methods. So, let us start our discussion. So, smoothing methods they are typically based on averaging over multiple observations, and the main idea is to smooth out the noise to uncover the patterns. So, we consider a number of observations, and because we are looking to uncover a different time series component, it could be trend or seasonality, and we would like to average out some of the noise, and then use the average series for our forecasting purpose. So, idea is to smooth out the noise to uncover the patterns, and averaging over multiple observations is typically done. These smoothing methods are data driven. So, we do not impose any predetermined structure. So, there is no structural modeling, any functional form of relationship that is assumed and implemented in smoothing methods. It is totally data driven. So, the model building we learn from the data itself. The different components of time series, they are learned from the data itself, and then they are used for forecasting purposes. Suitable when time series components change over time. So, typically regression based forecasting method that we have discussed in previous few lectures. So, that is more suitable when there is that the components they do not change quite frequently, and therefore, we can structurally model them, which is why we use the regression models. However, if these time series components change quite often, then these regression based forecasting methods they might not remain useful, and therefore, smoothing methods are the one which can be used in such a scenario. Main advantage being that since they are data driven, so they can adopt and learn from the data and understand these changes in the time series component. So, typically smoothing methods differ by number of observations used for averaging. So, the number of observations, because typically these smoothing methods they are typically used for short term forecasting, because if the time series components they change quite often, then this short term forecasting is the the toughest task that is to be done in forecasting time series, and the number of observations that are to be used for this purpose, and specifically for averaging, which is part of these smoothing methods. So, that itself creates a different different types of smoothing methods. So, length of considered time series history. So, that is one variation that we see in different smoothing methods, and the second one is formula used to perform averaging. So, what is the formula? How do we go about doing this averaging? Whether we just take a simple average or we take a weighted average. So, how this averaging is to be done? So, the formula that is being used for this averaging operation. So, that can change from method to method. Then the frequency of averaging. How often we go about doing this averaging? So, that will also be there, and so on. So, you can see all these aspects, the different smoothing methods and a few things that we discussed: number of observations, formula used for averaging, frequency of averaging. So, these are based on the data. So, these computation are to be done on the data, and there there could be different smoothing methods depending on how these things are changed. So, we are going to cover two popular smoothing methods. So, first one is moving average method. The second one is exponential smoothing method. So, we will discuss one by one. So, let us start with moving average method. So, moving average this is a simple smoother, the simplest kind of smoothing that can be done on a time series. So this is mainly based on averaging across a user specified window of consecutive observations. So user has to specify in terms of the number of observation which are going to be useful for forecasting or analysis purpose, and of course that can be determined by doing some trial and error or some experimentation. So that, and again domain knowledge and experience with the time series forecasting and analysis, that is going to help the user in terms of selecting a particular window for this averaging. So once this window is known to us, suitable window size is known to us, then averaging operation, that is part of moving average, that is going to be performed on those consecutive observations. So what this averaging operation essentially does is it generates a series of averages. So we get a time series which is based on these averages value. So again there are two types of moving average methods that are popular. So first one is centered moving average. So in this particular method, this typically this particular method is used for time series analysis and not for forecasting. Why? That is also mentioned here. Since consecutive past and future values of a time point are used for averaging. So we are going to use past and future values. So for a given time t, if we are also going to include t plus 1 and t plus 2, which are future values with respect to a given point t in this averaging process, then of course this method cannot be used for the forecasting, because in forecasting scenario the average values are not known, right. Otherwise if they are known, then there is no point of forecasting. So centered moving average is typically used for time series analysis, where we try to understand the time series, analyze its understand its component and behavior. So in that sense, centered moving average can be good, provide us good mechanism to create visualizations and understand the time series. So past and future values, they are taken in this particular method, centered moving average, for the averaging calculations. The second type of moving average approach is trailing moving average. So this is the method which is actually used for time series forecasting, and in this case most recent values. So we look at, if we are at time point t, then we look at the most recent values at t minus 1, at t minus 2, t minus 3 and so on, and these most recent values are then taken for averaging. Of course, as we have talked about, it is the user which is going to specify the window of these consecutive observations, or this window can also be determined by experimentation, as we will be discussing in this lecture itself. So trailing moving average is the method that can be used for time series forecasting. So let us understand these two moving average methods in a bit more detail. So first one, centered moving average. If we take this example, a centered window with width 5, w is equal to 5. So it can be depicted in this fashion. You can see this arrow is depicting this time series. So we can see t minus 2, t minus 1, t, and then t plus 1 and t plus 2. So t plus 1 and t plus 2 are the future values, and t minus 2 and t minus 1 are the past values. So now these because the window size is 5, so these 5 observations, these 5 consecutive observations are going to be taken for the averaging operation. So you can look at the second point, value of centered moving average MA at time t is computed as below. So here you can see y. So this is the generalized equation that has been written. So for any time t, a moving average can be computed like this: y and this t minus within parenthesis w minus 1 divided by 2, then so on, yt minus 1, then yt, then yt plus 1 and so on. All this is divided by the window size w. So if you look at this, we are simply computing the average for a number of consecutive values. So, we decide on the W, we take those consecutive values and take the average of it, and that average is being used as the moving average value. You can also see where W is the window width. Now, how do we select window width? So, we would be discussing this particular thing quite often in this lecture. So, the main idea is to suppress seasonality and noise to uncover trend. So, if that is the idea, then for a time series having seasonality component, length of the seasonal cycle could be one good rule of thumb to select a particular window size. We would be again discussing how do we select a window width, few more details in the lecture. Now, let us move to the trailing moving average, which is the method which can be used for the forecasting. So, again if we take the same example, we take the trailing window with width W is equal to 5. So, it can be depicted in this fashion. You can see here this is the time t, and then we have time t minus 1, the most recent value, then t minus 2, t minus 3 and t minus 4. So, you can see it is the most recent values or the past values which are going to be used, past consecutive values which are going to be used in computing moving average. Therefore, this particular method can be used for time series forecasting. If you are interested in the formula how this is going to be computed, so this is how we can write it. So, value of one step ahead forecast f t plus 1. So, using those values till time t, we are going to we want to forecast one step ahead in the future. So, this is represented by indicated by capital F t plus 1. So, this can be computed as below. So, you can see f t plus 1 equal to y t plus y t minus 1 up to the y t minus within parenthesis w minus 1 divided by w. So, again this is also in a way a simple average calculation that is being done. So, we need to select a window size, and that those number of observations are going to be taken, and that average is going to be the forecasted value for the next. So, the previous few values, and they are being averaged out, and simply that averaged value is being given as the forecast for the next point. So, this is how it is being done. If we are interested in k step ahead forecast, then f t plus k equal to is going to be equal to f t plus 1, because we are assuming at this point that we have the values up to point time t. So, therefore, for any even for more k value more than 1, we have the same information. Therefore, the best forecast that can be done is also going to be the same. So, f t plus k also essentially becomes f t plus 1. So, this is the trailing moving average which can be used for time series forecasting. So, let us open our studio and we will do few exercises to understand these concepts in a few more detail. So, if we look at so what we are going to do is we will first load this library. Again the same data set we are going to use bicycle ridership. So, let us import this data set. So, you can see in the environment section 159 observations, 2 variables. Let us remove any columns if there are any. So, this is the data frame that we have, structure of the data frame. We have the month information and the riders information. So, let us create a time series object from this. So, TS is the function for this. So, let us run this code, and the time series object, as you can see in the environment section, it has been created here. Let us again create a plot. So, the same data set that we have been using in this module, you can see this is the time series that we have. Now, what we are going to do is we will first implement the centered moving average, and in this we will take this annual seasonality. We already know about this time series. So we know that there is annual seasonality W12. So we are taking that as the window width for this example, and we are going to use this filter function to implement our centered moving average. So let us find out a few more detail about this particular function. So let us open the help section. Let us have a look at the filter function. So you can see this function linear filtering on a time series applies linear filtering to a univariate time series or to each series separately of a multivariate time series. So let us look at few more details. So you can see first argument is the time series, the second argument is the filter. So then if we are interested in few more details, for example this argument sides. So this argument is important for us right now. So this is if the sides argument is 1, then filter coefficients are past values only. So you can see if the this case scenario is mainly applicable for trailing moving average, but right now we are going to implement the centered moving average. So therefore we need to specify sides too, which is for centered around lag 0. So again there could be two scenarios here. In this case the length of the filter should be odd, but if it is even, more of the filter is forward in time than backward. So if the window size is an odd value, then there is no problem, everything is going to be centered around lag 0. So if it is t and the window size is 5, then we are going to have the t minus 2, t minus 1, and then t plus 1 and t plus 2, no problem. But if the window size is even, then how do we compute the average? So because the if you take t, and so there could be one scenario that you take if the window size, let us say window size is even and it is let us say it is 4. So you can either take t minus 2, t minus 1, t and t plus 1. So it is just one value which is into the future. So this is one way to compute average, or you can take t minus 1, t and then t plus 1 and t plus 2. So there are two values in the future and just one value in the past. So the the average is going to be more futuristic. So the more of future values is going to be accounted in the model. So how do we, so in this case the filter function, it is going to take the second case. That means if the window size is 4, so t minus 1 t and t plus 1 and t plus 2 is going to be the scenario for computing the average. So this implementation of filter function is essentially going to do this. So we should be aware about how these computations are going to be performed. So if we look at the first 12 values of the time series, the number of riders, so these are the values. Now because the window size is 12, so we need 12 observations to compute average, right. So and since we are implementing centered moving average, so the specifically since the window size we already know it is even value, and we already see what the filter function does. So the first value is going to be come at the 6th point. So at this point, so 5 observations in the past and 6 observations into the future, they are going to be considered for computing the this moving average, and that value, first such value is going to be computed at point number 6, because for the previous 5 points we do not have sufficient information. So those values are going to be NA. So first meaningful value is going to be created at point number 6 and so on, right. Reason being, as I said, 5 values we need in the past, and then remaining can easily be found out. 6 values can easily be found out in the future. So from in this fashion these values are going to be computed. If we look at the mean of these values, so since these are the first 12 observation, and for the first value these are the values which are going to be used. So the value is going to be come out to be this much. The mean is, this is the going to be the value for this moving average. So we can use the filter function to obtain these values for the whole series. So, we will get the averaged series, time series. So, we can use the filter function, then the time series object, and then we are using the filter. So, you can see the filter is 1 by 12. So, essentially because the window size is 12. So, this in this fashion we can write and we will get this. So, essentially if you look at this second argument, essentially we are specifying the weight for different values, and that weight is nothing but 1 by 12, because essentially we want to compute the simple average. Then sides is 2. So, let us compute this and let us have a look at the first 10 values of this. So, you can see it is the 6th value which has been computed, other values are NA because information is not known, and then so on, then other values have been computed. Similarly, at the tail side of this vector also we will get some NAs. Now, what we can do is in the plot that we had, we can add this moving average that we have just computed. So, you can see here in the plot this red line has been created. So, this red line has been created using this centered moving average approach. So, we can see how this particular line. So, this seems to be a U-shape kind of curve, but you would see it is not exactly U-shape like we did in the regression based forecasting, where it was the perfectly U-shaped. We did the quadratic modeling. However, in this you can see that in this centered moving average, it is in this fashion, it is going to predict the going to explain the series. Now, this averaging, as we talked about the moving average methods, they can differ in the fashion the average is being computed. So, we are going to take another, we are going to implement another approach for taking average. Specifically, this is applicable for even window width, which is the case now. So, first we will capture this length, number of observations, and then what we are going to do is we will initialize a time series in this fashion. So, all the values are going to be NA. So, they are going to have these many NA values equal to the number of observation that we have in this series. So, this has been initiated, you can see centered MA2 159 values. So, all these values are right now NA, right. Now, we are going to run a loop, right. So, this loop, if we look at this, this is taking this centered MA value which we have already computed, I minus 1 and I. So, what this is essentially going to do is we will take if for example, if the width was 4, then we are going to take first the average value for t minus 2, t minus 1, t and t plus 1, and this value is going to be computed by this, and then we are going to take this value will the second value will give us the value for t minus 1, t plus 1, t plus 2. So, in that sense we will get the two values which have already been computed, and we will take the average of these two values, and that value is something that we are taking at the as the final average, right. So, this loop will give us a new way of averaged time series values. So, we will run this and then have a look at the first 10 observation. So, you can see the first value is now not at the 6th point, but at the 7th point, right. Region is also quite clear because the way this value has been computed, and the value comes out to be 308.875. Now, again we can add this line also here in the plot. So, you can see a green line has been added to the plot, and you see the red line, the previous centered moving average and the second approach for centered moving average, they are there is slight difference. Sometimes red line is above green line, sometimes the other way around, right. So, because of the way computation has happened, these values are differing. So, it is important the way you are defining your how you want to take average, and because later on which one is doing better, of course it can be checked if it is for a forecasting model. In this case, this is this is centered moving average, so this is to visualize the series. However, if it was for the trailing moving average, which is used for forecasting, we could have compared the performance and seen which averaging method is helping us in predicting the series better and forecasting the series in much better fashion. So, this brings us to our the next approach, trailing moving average. So, now we will implement this. So, let us create this TSV. So, we are taking these many observations which we want to be part of the training set. So, let us compute this time series vector. Let us plot this. So, this is the plot. So, these are the observations from 2004 to 2016 which are going to be part of this model training per set. So, now again we are using the filter function, right, and in the same fashion we are going to now this argument has changed, size is 1. So, only the past values are going to be used. So, we will implement this. Now, again we are going to initialize this particular variable and we will capture the length, and now we are going to apply on the test set. So, you can see we are going to apply from 13 NC1. So, we are going to compute these values MA forecaster using this trailing moving average approach. So, essentially we are computing the forecasted values for the training set observations. So, let us run this. Window width is here again is the same 12. So, we will get these values, you can see. So, these are the forecasted values. So, these have been computed using the trailing moving average approach. Now, we can again plot this. You can see this is the plot. So, this is the plot for plot using the trailing moving average, and this is one approach that can be used for forecasting. So, we are interested in looking at the values, forecasted values, actual values, forecasted values and the error. So, we can see here. So, you can see up to this point there are going to be no forecast and residual. Then from this point onwards we will start to have the forecasted values and the residuals also. So, in this fashion we can implement this model. If we want to find out check the performance of this trailing trailing moving average model, we can do this. Let us load the R minor library and let us call this function M matrix. You can see actual values first TSV train and then the forecasted values, and these are the 3 matrices that we are going to use, and we will get the performance. You can see here. Similarly, if we are looking to plot this, so we can do the same. You can see 2016 to 2017 we can again create a time series object, we can plot this, and we can apply the model here, MA forecaster test. So, we can apply we can initialize this. So, all the NA values we can initialize, capture and in length, and then again run this loop to get the forecasted values for the test set, and we can add here in the plot. So, you can see the same value has been used for all the points in the test data set. It is the same forecast which is applicable, because in this model we will get only just one value, because no future value is known after after this point 147. So, for the 1 step ahead, 2 step ahead, 3 step ahead, all those forecasts, it is the same value that is going to be used. So, we can have a look at the this actual value and forecasted value. You can see it is the same forecast which is being used here as we have discussed before. Again performance also for the test set also we can check. you can see this is the performance. So, we can see here if we want to compare the performance. So, we see the performance is going to be much worse in the test data set. You can see MAP value is 3.18, MDA value is 96. So, if we look at the test set performance, you can see this is much worse. MDA value is on the higher side, MAP and MAC, all these values are on the higher side. So, mainly because the same forecasted value is being used for all the observations. So, let us go back. So, this is how. So, till now what we have discussed, we have been able to talk about centered moving average and trailing moving average. We also saw how we can go about computing and implementing these models for our time series, the bicycle riders data set. So, let us discuss a few more points about MA methods. So, as we have seen till now that these are suitable for forecasting series with no trend or seasonality. So, because we are essentially averaging the series, and essentially these methods are typically used for short term forecasting. So, it is much better if we have a detrended and deseasonalized series and we apply moving average method on that detrended and deseasonalized series, then short term forecast can actually be improved using these methods. So, typically these methods are suitable for forecasting series which does not has a trend or seasonality. So, this is something that we will do in the next lecture. Well, we use the residual series that we have built in the previous lectures and apply MA methods on that particular series. So, if seasonality is present, what is going to happen is under forecasting the peak seasons and over forecasting the non peak seasons is something that is going to happen. So, that is why this is not suitable if the series has a seasonality component. If trend is also present, then forecast will lag behind. That means under forecasting if there is increasing trend and over forecasting if there is a decreasing trend. So, essentially these moving average methods can be used to forecast or understand the level and noise. So, essentially what you are trying to do is you are trying to forecast the level of the time series and you are trying to average out the noise. However, if the trend and seasonality component are present, then the forecasting of this level can be will take a hit and therefore performance will go down. Therefore, it is these methods are typically used when we have already detrended and deseasonalized the series, and then these methods can be used to forecast the level of the series and by averaging out the noise. So, we will stop here, and in the next lecture we will talk about how do we go about detrending and deseasonalizing a particular time series. Thank you.